So you should now have a circuit with a 7-segment display and 7 wires connected to it, plus a switch and its power supply. So a bit of a busy circuit board. Let's learn how to actually program it. Now, if we were going to program it segment by segment, we would have to do digital writes to each of the segments one by one. And if we were to do that, we would need something like 100 lines of code, if not more, just to set up the numbers 0 through 9. What we're going to do instead is we're going to use what's called a library. So head over to your code window and open up a new sketch. Now, down the left-hand side, you've probably already noticed, but we have a series of icons. We've got Sketchbook, we've got Boards Manager, we've got Library Manager. I'm going to get you to open the Library Manager, and in the search box, type segment. This is called a 7-segment display, and if you look down, there are a lot of different libraries. Libraries are bits of code that have been written by other people that will allow us to reuse that code over and over and make our lives easier. The code we're actually going to use is this one by Blake Torneo. So I'm going to select version 3 and I'm going to press install. It should say installing and then installed. If it's done that, we can now close the Library Manager. If you want to find out what you've just done, you can go File, Examples, and down here there are some examples that go with that library. But what we're going to do is we're going to recreate our push button code and attach it to a 7-segment display. So I may go quite quick, but remember the code is attached to the course. So first thing we're going to do, as we did before, I'm going to define my switch on pin 2. And then we had 5 variables. We had our counter, which is an integer and starts at 0. We have our switch state. We have our last switch state. Remember, if these are the same, then we know the button's not been pressed. We have our unsigned long, which holds the time. And then we have our debounce time, or our miniature delay time. Those are in milliseconds, remember? Hence the reason why we need to use longs. So we're going to do our setup exactly as we did before. So our switch is an input. We haven't got an output this time. I'm going to leave the serial port connected just so that we can debug it, debug the code. And that's it for the setup. The last thing we're going to do is we're going to copy from our last sketch the counting code. So we'll just go through this again. We're going to read the value of the switch button, and we're going to store it in something called current switch. If the current switch does not equal the last switch state, then we know that the button has been pressed or released. It's changed. So what we're going to do is we're going to take a sample of the millisecond timer. If the millisecond timer minus when we sampled it is greater than our delay time, then we now know that something has happened. And if our current switch state is not the same as our switch state, then we know what's happened is someone's pressed the button. So we're going to set the switch state. If the switch state is high as well, so we've just pressed down, then we're going to count. We're going to output that count to the serial line, and we're going to update the value of the last switch state. So that's where we got to last time. What we're now going to do is we're going to add our 7-segment display. So to be able to use the 7-segment display code, the library, we need to include it. So we go hash include. And then we use an angle bracket, otherwise known as a less than sign. Segment.h, and then close the angle bracket, the greater than sign. Segment has got a capital H, a capital S, because this is the name of the library. By doing that, what we're doing is say, let's bring in the code that's in segment, and that will allow us now to use that as if we'd written it ourselves. All we want to do is we want to create something from segment. We want to create a new segment display. So we're going to type segment as if it's a variable type. It is essentially a variable type. And we're going to call it sev-seg. Sev-seg for 7-segment. Now we need to tell it where the wires are for each of the LEDs in our 7-segment display. And we know, because we wired them up right, that they are on pins 3, 4, 5, 6, 7, 8, and 9. And then the last thing we need to do is we need to tell the library whether we're using a common anode display or a common cathode display. Ours is a common negative, a common cathode. So we're going to set the value true. True means we've got a common cathode. If we had a common anode, we'd use false. Now we have this device called sev-seg, and the software now knows which pins control what. So that's it set up. If we now go down into our loop, what we're going to do is we're going to output to our 7-segment the last digit of the counter. Now the counter is counting in decimal, and so the way to get the last character is a little bit tricky. What we're actually going to do is sev-seg dot display, and we're going to take the count, and we're going to do remainder division by 10. What that's going to do is, if you think about it, 10 divided by 10 is 0, remainder 1, remainder 0. 11 divided by 10 is 1, remainder 1. 9 divided by 10 is 0, remainder 9. So by doing this, it's going to give us the last digit. Unfortunately, this display requires a character. Now there is a way. What we're going to do is we're actually going to do a plus, and then we're going to put a plus 0, but instead of using a number 0, we're going to use a character 0. So we're going to place it inside single quotation marks. That is a bit of a hack, but it's one way of forcing a number to be a character as far as Arduino is concerned. If we now verify this, we get no issues, and we upload it. So let's have a look at the serial monitor. We're getting lots of zeros. Let's have a look at the actual board though. And what you can see is we have a 0. If we press the button, it goes to a 1. Press it again, it goes to 2. only go increments when we press down and we create the high. Five, 6, 7, 8, 9, 10, which is 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. So we've now built a counter that works whenever the button is pressed. To count the number of presses that have been made. If we go back to looking at the serial monitor, you'll see we're at 60, 61, 62, 63, 64, and so on. What it's doing though is it's only outputting the last digit. Don't know why there's a floating 7 there. I think it's because of the speed of refresh rate on the screen. It's not the most efficient system in the world, and eventually we'll hit the upper limit of the integer, which is 64,000 and something, and at which point it will roll over. But that's a long way off. I wonder, could you think of a system where you might use a switch to count people coming in or out, or Nerf darts hitting certain parts of targets? Can you think of any other situations where you might want to count something? At the moment, we're counting up, but it wouldn't be hard for you to think about how you might be able to get it to do a count down every time you press the button. So instead of getting higher, it starts getting lower. There's only one symbol you would need to change in the whole code to make that happen. And it's something to do with this if statement. Have a think, have a play. You've now got the ability to build a counter based on a simple switch. In the next part and the last part of the White Belt series, we're going to update our code to use a sensor instead of a switch. So instead of having a physical switch, we're going to have an optical switch. But that's what we'll do next. So for now, see you later.